When vehicles were first invented in the 1870s and 1880s, there was no limit to how far they could travel. If you had enough gas, you could go wherever you wanted. But when rockets and space shuttles followed just a few decades later, offering genuinely limitless travel beyond even the bounds of Earth, why hasn't that happened? Hello and welcome to Z. And today, we're delving further into the real reason why NASA hasn't left the solar system yet. Do you require answers to the major questions? Then why not subscribe to Z for more videos like this one and ring the bell for more thought-provoking information. Technically, today's title is probably a touch unjust because NASA has developed equipment, at least, that has gone to the end of the solar system and beyond, at least according to one understanding of where the edge of the solar system is. The Voyager 1 spacecraft formally left the solar system in 2012 and is now flying in interstellar space, according to NASA. In 2018, Voyager 2 followed suit, 6 years later. Both were launched in 1977 with the intention of studying radiation and planets, but also famously carrying a golden record containing vital information about humanity for any prospective alien species that they could encounter. By some metrics, though, the Voyagers haven't completely left the solar system because they haven't traveled beyond the Oort cloud and won't be able to for thousands of years. The distances involved are simply too great for even NASA's flagship long-distance probe project to overcome. But, aside from the Voyagers and other equally robotic pursuits, one thing is certain: no one has ever come close to exiting the solar system. No crewed mission from NASA, or any place else, has yet to reach beyond the moon. In fact, no human has left low Earth orbit since the last Apollo mission, Apollo 17, all the way back in 1972. There are a variety of reasons for this, although those reasons aren't necessarily the same ones that apply to our reticence or inability to reach interstellar space proper. For example, NASA has had ambitions to send humans to Mars for a long time now, and there are several methods in which it may technically be done. But state-sponsored Mars missions are getting pushed back and shifted about an order of urgency due in large part to the fluctuating character of U.S. politics. Critics believe that there's a lack of continuity in terms of vision and financing, which in turn undermines the degree of incentive that NASA has for going in the first place. Until relatively recently, it might be claimed that there's been a lack of competition. While in the first space race it was the US versus the Soviet Union, propelling America to reach the moon in double-quick time, there hasn't been a similar concentration with Mars or anywhere else. When it comes to interstellar space, though, to anywhere beyond the solar system, those conventional limits of funding and rivalry don't cover even a quarter of what's truly keeping us back. Interstellar space comes with an entirely new set of issues regarding spaceflight, and no one has truly planned for it. Escaping the solar system takes a lot of energy and a lot of time. The Voyagers are still roughly 40,000 years away from coming even close to any other star system in space, depending on the peak speeds that they're capable of. But, in any case, they can't carry on forever and ever. One day, possibly soon, we will either lose communication with them forever, or they will come to a standstill and die. Because of the enormous speeds and distances involved, we truly need a new type of space vehicle even at the probe level to make it work. We also require a new form of rocket fuel for electricity. Current shuttle fuels are primarily chemical-based fossil fuels that are simply too heavy and inefficient for interstellar travel. The typical issue is that adding more fuel, which is now required, adds weight to the craft as a whole, which requires more fuel to achieve liftoff. It's a hopeless situation. To reach distant star systems, we need fuel with more power per unit weight. Ion engines, nuclear pulse engines, nuclear fusion rockets, and other advances have been proposed as solutions. However, while some vehicles have previously used variations of this technology, none are ready to leave the solar system, and certainly not with humans aboard. Consider how much living space a long-distance crewed flight would require, even in a hypothetical scenario where we can reduce commuting times to a few years or less, and the problems become clear. How can you handle something as large as that spacecraft through something as vast and perilous as space for as long as needed? Aside from technological obstacles, certain human aspects of prolonged space flight pose significant challenges. How will the human body react to a 24-hour environment? What will happen to the human mind? NASA has been investigating such concerns as part of its human research program for decades, with long-term deployments aboard the International Space Station supplying the majority of the astronaut test subjects. The overall idea is to figure out what types of challenges we'll have to deal with if we ever spend extended periods of time in space. Concerns include radiation exposure, the risks of isolation, equipment failure, the impact of zero gravity on muscular tissue, the psychological strain of seeing the unending black void of space on a daily basis, and others. Low gravity, for example, has been found in studies to induce blood clotting and blood flow difficulties in astronauts. In general, NASA discovered at least 30 different concerns that required significant evaluation and answers in a 2015 assessment on the risks of spaceflight. At the moment, leaving Earth in any capacity is difficult to reconcile with astronaut welfare, let alone sending humans on potentially lifelong voyages into the unknown, never to return. It's no surprise, then, that unmanned probe missions are virtually invariably launched instead. But they too face the same difficulties, minus the human challenge. Is it even conceivable to propel a probe fast enough to leave our solar system and reach another star? Even at its most basic, is this a voyage that humanity as a whole will not live to see the end of? Are there any solutions to this seemingly intractable problem? Again, skeptics claim that the apparent impossibility of it all is only the consequence of little research. If this were regarded vital enough, NASA and other agencies would be considerably further advanced in their effort to reach other star systems by now. NASA has received less than 0.5% of the government budget each year since 2012. When the first space race was at its peak in 1966, NASA claimed a stunning 4.41%, over 8 times the amount that it earns now. Back then, space travel was considerably more important. It is now lower down, yet the obstacles are far more daunting than even the moon landing. However, there could be a variety of reasons for that lack of support. Because, after all, what is the ultimate purpose of interplanetary travel? Aside from ordinary curiosity, why does humanity desire, or need, to travel that far at this time? NASA, for example, would definitely require a more convincing and urgent reason to leave the solar system, such as proof of life in Alpha Centauri or revelation of an impending cosmic calamity that could wipe out our star system. We don't have either of them right now. As a result, we're in a pickle. What's your take on the situation? Should NASA go above and beyond? Should we, as a species, prioritize long-distance space missions? Or is it all irrelevant because it's almost certainly impossible to begin with? For the time being, we know that we haven't even begun to grasp our own solar system, so there's still plenty of work to be done. We also know that if a probe or even a person ever found a way to leave our particular planetary neighborhood, it would be a one-way trip. They were not going to return. Even if they did survive, we'd probably never hear from them again. Finally, there are numerous reasons why it isn't working out. But it is why NASA has failed to leave the solar system. What are your thoughts? Is there anything we left out? Let us know in the comments, and don't forget to subscribe and ring the bell to stay up to date on our latest content.